we have to construct a frequency distribution and a relative frequency distribution using 5 classes. So in order to answer this question, the first thing we have to do is that find the smallest data value. So if you look carefully to these numbers, so you see that the smallest value in all these numbers, right? So this is the 67, right? So this is the smallest observation. And then the next thing we have to do is that find the largest data value or the largest observation. And if you look among these numbers, so there's 74, right? So 74 is the largest one, right? So smallest that is 67, and then largest so that is 74. And we are asked that we have to use 5 classes, right? This is 5. So sometime it's not given. If it's not given, then you can pick any number of classes from 5 through 20. Again, this is not strict rule, but generally it depends upon the size of the data, so we can pick anything from 5 through 20. But here in this problem we are told that, okay, so use 5 classes. So once you determine this, or if it's given like in this problem, so the next thing is that find the class width. So even before that, you have to think of where you want to start. So usually we start around like the smallest observation, or if that smallest observation is not a nice number, so then you can pick the number, any nice number lower to the smallest observation. So here in this problem, so we have this 67, so this is really fairly nice number. Okay, we can pick as our this the smallest number as the lower limit of our first class. We can start from here, right? So then the next thing we need is like class width. Okay, so to figure this out, so what we do is that, so this is the rule that we use. So that is the largest number, that in this case is 74, minus the smallest one, which is 67, and divided by the number of classes. So in this case we are given there 5. So this would be 74 minus 67, so that is 7 out of 5, and if you divide it, so you get 1.4. Right? So now you want your class width to be like a little nicer number, so you can keep it 1.4, okay, but you can make it a little bit look like, okay, so make it a better number. So what I would do is that, so I would up a little bit, increase it, right, and make it to 1.5, right, like this way. So again, these you can adjust these class width, right? So upward if you want to. I mean, you can keep the same, but okay, if you want, you can do it, right, to get a nicer number. So I think that 1.5 is a nicer number looks than 1.4. Okay, so we have class width and we know where we want to start. So this is how we go. Then we make a table something like this one for our frequency distribution and relative frequency distribution. So in this column, in a commute time, so we would define our classes, then the next column frequency, the number of observation in that particular class, and then relative frequency. Okay, so first work on this column here. So we are starting with 67. The smallest observation is 67. So our class would be first class here, the 67 throw. Alright, so the class width, right? So 1.5, if you add it, so that would give us 68.5, right? So we don't want to include the 68.5, so we would say, okay, something very close to it. So we would say that 68 point, instead of 5, so I would put as 49 here. Or we can write it slightly less than 68.5. This is our first class. Then this next class will start okay, adding this 1.5 in this one, so that is 68.5. so this is the start of our next class, and then add the class width. So this would give us like number 70, but we have to be slightly less than 70, so we would write as 69.99. then alright, so then the next class will start, right? So adding this class width into lower limit of this one, so 68.5 plus 1.5 is 70. So then 71.49, and then adding to the class width, so that is 71.5, and then it would be 72.99, and then is 73 to 74.49. Right? And now we stop it here. So because you are the largest value 74, right? So it's already included, and we have already 5 classes, 1, 2, 3, 4, 5, right? So again, the smallest value, or any number, nice number which is lower than the smallest value, you can start with that. So our smallest value is 67, which is nice number, we start with that, and then add the class width to get the lower limit of the next class, right? So keep going like this way, and then the upper limit you can put a number slightly less than the lower limit of the next class, right? So it was 68.5, so we go a little bit lower, right? 68.49, so anything less than 68.5, right? Something like that. The next thing is that we would be looking into the data back, right? So there in our problem, and we would see that how many of the observations fall in this range, so 67 to 68.49. If you see that, so our observations are not in decimal, they are whole numbers. So we are especially talking that any numbers which range from 67 through less than 68.5, so which is 68, so 67 or 68. So looking into this one, so 67 or 68, so if you see this, so in the first column you have this 1 and nothing here, this second, third, fourth, fifth, and then this one sixth. So there are 6 observations in this range. So we would write it here in the frequency for this class. So for the next class, so all the observations which are more than 68.5 or 68.5 or more until 69.99. And if you see in our observations, because there are no decimal there, so only thing you can see is 69. So how many 69s appear there in this data? So if you count them, 69s, so here is 1, 2, 3, 4, 5. So there are 5 69. So you will write your frequency here 5. Then next for the next class, so 70 through 71.49. So the observations would be 70 and 71. So from here you can see that, so 1, right, so this is 170, then 71, 71, right, so 1 2 3 4 5 6 7 8 9 10 11 12 and 13. So there are 13. So there are 13 observations for this class. Similarly for 71.5 to 72.99, so the only number would be 72 here. So you see that how many 72s are there. So there are actually 2 of them, right? So in the first row this is 1 and then this is second one. There are only 2, right? So you put this 2 here. And then 70, next class 73 through 74.49, and there are 4 of them, right? So this part, right, so first column and second column together, this is called frequency distribution, right? So the next we have to also find a relative frequency distribution, right? So we have to do a little bit more work here. The first thing we have to do is that sum this up, and this is equal to 30 observations total. So for relative frequency, so for this our class, first class, which ranges from 67 through 68.49, so there are 6 observations. So relative frequency means that 6 out of 30. So 6 out of 30, and this would be in terms of decimal 0.200. So we are doing it to 3 decimal places because that's what we are asked to do in our problem, right? So it says that, so you have to go to 3 decimal places for relative frequency. So that's I wrote it here 0.200. The next one is 5 out of 30. So 5 out of 30, and in terms of decimal, so this would be equal to 0.167, so 0.167 approximately. Then next is 13 out of 30, so this would be 0.433. The next one is 2 out of 30, so that is equal to 0.067, and this last one 4 out of 30, so that's equal to 0.133. And this is our frequency and relative frequency distribution for the given data.